Hi everyone, in this video we are going to discuss about theorem number 11 from the geometry of circles. The theorem says that equal chords subtend equal central angles. That's the first part of the theorem, and the second part of the theorem says that equal chords cut off equal arcs. Let's suppose we have a circle like this having the center at the point O, and we have two chords which are of equal length. So let's assume that AB is equal to CD. That means the length of the AB chord is equal to the length of the CD chord. And also let's suppose that the AB chord subtends the angle alpha at the center. So this is the central angle for the AB chord. And similarly for the CD chord, let's suppose theta is the central angle. So as part of this theorem, we have to prove that alpha is equal to theta, and also we have to prove that the length of the AB arc is equal to the length of the CD arc. So let's get started with the proof. As you can see in the circle, OA, OB, OC and OD, they are nothing but the radii of this circle. Each of them is equal to the radius of this circle. So OA will be equal to OB, will be equal to OC, will be equal to OD. And also it has been provided that AB is equal to CD. I mean the length of the AB chord is equal to the length of the CD chord. And now if you look at these two triangles, the triangle OAB and the triangle OCD, they actually will be congruent. Why? Because they meet the SSS criteria of congruence, because the corresponding sides are of equal length. So these two triangles will be congruent triangles. And because they are congruent triangles, we can say that the angle opposite to equal sides will be equal. Now in this case, the side AB in the triangle OAB and the side CD in the triangle OCD, they are equal, because we have been already provided that in the theorem that equal chords would subtend equal central angles. That means the chords are equal length. That means AB is equal to CD. So the angle opposite to the equal sides will be equal. That means alpha will be equal to theta. That's according to the corresponding parts of congruent triangles are equal according to that criteria, which is abbreviated as CPCT criteria. So according to the CPCT criteria, we can say that alpha will be equal to theta. And that was the first part of the theorem to be proved. Now let's talk about the second part of the theorem. Well, in a previous video, we have proved that equal arcs would subtend equal central angle. Now in this case, think about these two central angles, alpha and theta. They are actually equal. We just proved that alpha is equal to theta. So if alpha is equal to theta, that means the arc that subtends this angle at the center, each of those arcs will also be of equal length. That's according to the previous theorem that we have already proved in the previous video. So we can say that the length of the arc AB will be equal to the length of the arc CD, because the subtended central angles are of equal size. That is why we can conclude that the arc lengths will also be equal. Also, I would like to mention one other thing, that from the diagram you can clearly visualize that larger chord will subtend larger central angle. If we are talking about two chords which are smaller than diameter, but one of them is larger than the other, then whichever chord is larger, it will subtend larger angle, and whichever chord is smaller, it will subtend smaller angle. That's pretty obvious from the diagram. And along the same line, we can also say that larger chords will cut off larger arcs and smaller chords will cut off smaller arcs. This brings us to the end of this video. I hope everything made sense. Thank you for watching. See you in the next video.